طيب بسم الله الرحمن الرحيم. So last time we talked about the features that exist in the internet or in the interconnection of networks that allows the internet to support multiple users with converging services where you have multiple services that can run on the same network infrastructure. So we talked about these features, including the fault tolerance, which is the ability of the network to work under faults, and the scalability, or the ability of the network to work under growing number of users without degrading the performance for each user, and also the quality of service, which is all about discrimination between the different users and the different applications, and tailor the network resources towards providing a diverse set of services and applications with high quality of service. And finally, of course, security, including the information security and communication security. Today, inshallah, we're going to talk about some service paradigms which are facilitated by the features that we talked about last time. So due to this high level of flexibility of the network to support diverse set of services and applications, we nowadays have very important and key service paradigms that are possible and they couldn't be possible otherwise in the past. So one of them is the bring your own device. So bring your own device, we mean by that is that we can use any type of device, whether it's a small, like tiny little of tiny bit of hardware, like Raspberry Pi or something, or a mobile phone, or an iPad, or a laptop, or a workstation, or a cinema screen, or whatever. So whatever device we have, the network has to tailor for this. And also we'll talk about online collaboration, which we will talk about what that means. Video communication, we'll talk about the difference between the two, and finally cloud computing. So the concept of bring your own device talks about the fact that the network nowadays is able to tailor the content based on the type of the device of the user. So if I have a website, the same website, if I use a mobile cell phone to access that website, I will see the content on this website in a way which is totally different if I use, for example, a big screen on a laptop or a workstation to browse the same website. So both the content itself needs to be tailored based on, or based to be custom, should be customized based on the type of the device of the user. So if the user is using a cell phone, it's different from a laptop, it's different from a big screen monitor or something like this. And not only the content has to be customized, but also this will imply using different resources from the network. So if I have, for example, if I'm using YouTube on a mobile phone, so the YouTube website will automatically detect that I'm using a cell phone to access this content. Therefore, YouTube will give me the low resolution video to be fit for the mobile device that I'm using. If I'm using a big screen, then I get high resolution video by default. So this is the concept of bring your own device. So it's like the network has to be smart enough. So I have content here, and I have a set of users with different types of devices, whether it's a cell phone or a big screen or a very small, tiny little screen. Okay, and the network has to come here in between. Okay, so the network should take a subset of this content, okay, and send it to the small device. And we do this, of course, by using some sophisticated techniques like encoding techniques, which can customize and compose the content in a different format. Okay, if I use a bigger screen, then I can get bigger set of content, which in that case will be a little bit of higher resolution. So if I have a bigger and bigger screen, then I get the entire content on this screen. So the content itself and the network has to be tailored for each type of device. Okay. Online collaboration here talks about a class of applications that involves the communication between people. Okay, so nowadays we can use IP phone, or we can use different set of devices to communicate between each other. Online collaboration talks about class of applications that is, on one hand, it's time sensitive, and we talked about time sensitive before. So it's time sensitive application, okay, which means that we're talking about potentially using voice and video to communicate between people, and that's, in that case, it's time sensitive. But also there is another condition here, which is highly interactive. Highly interactive. So if we assume that there are two people, only two people are trying to use collaboration to communicate using voice and video. So interactivity here talks about the fact that we need high resolution video to go not only in one direction, but in actually in both directions. And it's actually affected by the interaction between the people. So if one person is talking, the video on one direction is really is high quality, and it's consuming a lot of resources. If this other person is now talking, then the video on the other direction is consuming more resources from the network. So the network has to tailor not only in one direction but in multiple directions. So imagine that we on the internet, we not only have two people communicating, but in many cases we have a meeting like the one that we have now, and all of us are unmuted, and we have our cameras working, and we can interact with each other. So the network has to be very, very smart in order to tailor its resources in different directions based on who is talking at any point of time. So this type of applications is really challenging when it comes to network resource provisioning. So communication on the other side talks about a different class of applications where, yes, it's time sensitive, but it's not in that case interactive. So here we're talking about video on demand services. So video on demand services, like if we use Orido Triple Play, or if we use YouTube, or if we use Facebook broadcast, so video broadcast as well as lies under this category of applications. The difference between this application and online collaboration is that on one hand, the online collaboration requires bidirectional communication using video, okay? And also, the online collaboration is not a killer application on the internet like video communication. So if we take a look at the internet traffic, we see that about 80%, okay, of the internet traffic is categorized as video communication, in which case we as users, we use it to watch TV over the internet, like IPTV, or video broadcast, or video on demand. We usually consume huge amount of video traffic on the internet, more than we use the video to collaborate, or to make video calls between two or more people. So That's why the video communication as a class of application is by far the killer application of the internet. By killer application means that it actually consumes the majority of the traffic of the internet, and it introduces, of course, the biggest challenge when it comes to resource provisioning of the network resources over the internet. Okay, so this talks about the fact that as the world population increases exponentially throughout the years, the internet users, of course, increase with the same proportion, but the video content and the video traffic is actually increases with the same pace, if not even faster, due to the fact that more services are now available and people started to use them, and that creates a huge amount of video traffic over the internet. So this is the class of applications which is facilitated by the agility and the flexibility of the internet based on the features that we discussed in the last lecture. Another, last but not least, actually, it's one of the most revolutionary approaches that existed in the recent era, or the few decades back, which is the concept of cloud computing. The concept of cloud computing has revolutionized completely the computation or the computing field as we know it today. And to understand the concept of cloud computing, let's assume that I'm a business owner. Okay, as a business owner, I have, or an entrepreneur, and I have many small devices, old devices. Okay, I have many old devices. Each of them has a very low storage and very low computation speed, like CPU, small CPU, and only a hard drive of, let's say, like half a tera or something like this. Okay, so if I'm an entrepreneur and I want to build a big, application or service, okay, and provide it to many users, okay, let's say like 1 million users, something like this. So as an entrepreneur or as a business owner, how can I do this? If I use any of these devices to provide my service, I won't be able to, because I have very sophisticated, huge task to provide this service to millions of users, and I cannot do that using any of these individual servers or machines. Okay, so instead, cloud computing comes into this picture and say, okay, so I'm going to consolidate. I'm going to consolidate all these resources, okay, and view it to the business owner and potentially to the users as only one humongous machine that has a storage which is equal to the summation of the storage of all these devices, okay, and has computational speed, again, which is proportional to the number of physical machines that I have, right? And then view this to the users as if it's one big machine. Well, if I do this, and I do this seamlessly, okay, to these users, they are using humongous machine, even though this humongous machine is actually a consolidation of very small and old devices. Okay, so this concept is made available through an underlying technology which the cloud computing uses, which what we call virtualization. Virtualization. Okay. So virtualization creates an intermediate layer between the users and the physical devices, such that the users can perceive these physical devices as if they are one machine, one humongous machine. Using this concept, I can run very sophisticated tasks, and then this cloud or this virtualization layer will take care of parallelizing my huge task into smaller tasks that can run on these physical devices. Okay, so that's the concept of cloud computing, and using this simple concept, we have actually gained very critical features. So this has allowed us to have very high flexibility in the organization, because now I can add more physical devices to increase the computation, okay, and increase the amount of resources in my cloud incrementally, and therefore I can add or remove or throw away or bring more devices, and therefore I can have bigger and bigger cloud. I can have agility and rapid deployment by the fact that I can add and remove physical devices as I want, and the cloud allows me to always perceive all these machines as if they are one humongous machine. That will allow for rapid deployment, because then I can add and remove as I wish, and with high level of flexibility, I can create bigger and bigger cloud. It's of course reduced cost, because now instead of throwing these old devices away, okay, which is what we used to do in the past. Actually, in the past, before cloud computing, we could, if a device becomes old, I cannot do anything with it, so I typically throw it away and buy a bigger server. Okay, and if I need to support or to provide service to a high number of users, I need to buy a big, huge server, which is proportional to the number of users that I want to provide the service to. Now, what I do is that with the concept of cloud, I can always bring all these old devices and create one big humongous machine out of them using the concept of cloud. So it refocuses now the IT resources. It actually revolutionizes even the business models. Even the business models now have changed completely, because now we have the concept of cloud as a service. Okay, so for example, we've all heard about Amazon, and the Amazon, they have Amazon AWS. Okay, this is by Amazon. So Amazon AWS is a public cloud now, which any user can actually access and build his or her own machine. Okay, virtual machine. It's a totally virtual machine, and you can specify all the configuration specs for this machine and the duration of time where you need it. And Amazon AWS will take care of physically, consolidating the resources required to build this machine for you. It's actually a virtual machine. It does not exist in reality. And you can use it for a duration of time. And here, this machine will be dismantled and somebody else can use it. So now we are using the concept of cloud as a service. And that's a very new business model that we can use now the cloud to provide a service by building these virtual machines for a duration of time, and then reusing the resources for other users as they come along. So that concept is really nice, and it changed the concepts and the mentality that we think about IT resources. Okay. Any questions so far, Shabab? So this is cloud computing. So as we have talked about cloud computing. So what does the network have to do with this? Okay. So we need to talk about network. What is the network have to do with this? Well, the network actually comes into this by saying, okay, so I have these small devices, right, as we said, and then we have the cloud, Okay, the cloud is nothing but actually in physical world, it's actually a set of switches and routers here. Okay, so these devices have to be physically connected using a network, which is what we call data centers. So data centers are the physical realization of the cloud. So cloud is actually a logical consolidation of these machines. Okay, so you can think of it as the logical topology. But data centers are physical network that allows me to connect physically all these different machines together to form a big network. And of course, in that case, clouds are mainly designed using wired and in many cases fiber optic links here, which allows all these machines to communicate with each other very, very fast. So these data centers, they include some servers with different capabilities, and these servers are connected in the backbone or connected physically using routers and switches and a very high speed media, which allows these machines to, of course, communicate very fast. Okay. So data centers is in brief is the network physical realization of the cloud. Okay. All right. So with the concept of cloud nowadays, we have a very nice set of applications like smart home. So some applications they came about because of the fact that now we have the clouds, and the clouds allow us to have a centralized computation which can be used to control set of houses. So smart home applications talk about the fact that my house is very, very smart, and I can use the cloud to control the appliances in my house. So before I go home, I can just start cooking some stuff automatically, and I can activate that using my mobile, so that by the time I get home, I get some very hot and nice meal ready for me. I can even control my car using I can control all the appliances in my house using the cloud. And as we have heard, there is the Google Alexa, and Google Alexa is actually the smart home solution that Google provides to interact with the Google Cloud, and can be used to control your appliances at home, either remotely or by voice commands or something like this. So the concept of smart home has come about, or has been realized using the cloud technology. On a different note, we have also the different technology called power line networking. This technology is, in fact, is almost obsolete now, and it's not used. Uh, this technology here talks about the fact that the power lines that we have in our houses, which include the 220 volt power lines, these power lines, they can be used for data communication. We don't see this nowadays very widely used because of the fact that, of course, in our houses now, we enjoy wireless. So wireless technology is the predominant technology in our houses now, and everything is wireless. So we don't need to actually use power line communication for data communication. But this power line networking uses similar concepts, similar to DSL, which we talked about last time, which is called digital subscriber line, which uses landlines for data communication. So phone lines is not power lines. Phone lines, they use, of course, low voltage for voice communication. And we have used phone lines to provide data communication. So similarly, with similar concept, we can use the heavy power lines, okay, the ones that are used for to control the electricity in the house, lights and so on. So we can use that for data communication. And again, it uses the same concept similar to DSL. But in any case, We are not using this power line networking technology nowadays because of the fact that everything is now wireless, and we enjoy wireless at home, and we can use wireless to communicate between the devices in the house. Okay. So any question? Any question about this? Any questions? So this is actually the end of chapter one. In chapter one, we talked about networks and the internet, and how we can interconnect the devices and media. So we talked about the different types of devices, whether it's end device, whether it's network device, and how we can connect these end devices and network devices using different types of media. And also we talked about the concept of classifying the network based on the geographical area. So we talked about local area networks, we talked about wide area networks, and then we talked about how we can provide very high flexibility in the networks to be scalable and to have fault tolerance, and to provide different quality of service, and finally to provide high level or low level of security based on the application. And finally, we talked about service paradigms that have come about because of this high flexibility in the network, including the concept of bring your own device, where we tailor the content and the network resources based on the type of the device that the user is using. And also we talked about online collaboration, where we have very high level of interactivity between the users, and now the network has to refunction or format itself based on who is actually communicating at any point of time. And then we talked about video communication, where it's actually the killer application on the internet, and more than 80% of the internet traffic uses video communication, whether it's in a form of a YouTube video or watching IPTV or something like this. And we also talked about the concept of cloud computing, and how we can turn a small set of very resource constrained devices into a huge, humongous machine, which have high level of flexibility to provide different diverse set of resources to the users. And finally, we talked about different technologies like smart home and power line networking. So that's the summary of chapter one. And as we said before, chapter two is covered totally in the lab. So we jump from chapter one directly to chapter three, where we need now to change the format of the instruction of the course. So we will switch now to flipped class, where I assume that you have watched the offline videos, at least the first video out of the 3 videos that I posted. And now I will go through chapter 3, where we need to talk about the key concept in the first video, and pay attention to the briefing that I have to do. From now on, I will start with clean sheet like this, and then I can go through the briefing, and then we will jump into some activities. Okay? So any question about chapter 1 before we move to chapter 3? Okay. 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 So I need some interaction every now and then to just make sure you're following. All right. So, all right. So in chapter 3, the first concept we talk about, which is the communication. So communication system components. So the first topic that you should have gone through in the offline material, which is the communication system component. So we need to describe and define clearly the different components in any communication system. So in order to visualize that, the material actually talks about an example from real life. So if we have two people, okay, that are trying to communicate, and they are trying to communicate, يعني they are having conversation. So in that example, what we try to do is that a person, let's say that this person is actually the source and this person is the destination, okay, which means that the person in the source side, he or she has some set of thoughts, okay, in his brain or her brain, okay, and these thoughts needs to be conveyed, okay, or transferred to the other side, okay. So I have certain ideas in my head and I want to convey these thoughts, okay, through conversations to the other side, okay. So based on that example, we can define a set of components in this type of communication system, which is very much similar to the communication system components that we have in networks, okay. So in our networks, we have certain components which start from the source side, okay. So starting from the source side, I have some ideas in my brain. So the first thing I should do is just to create some well-structured sentences or messages, okay, that I need to send to the other user in order to convey these thoughts, okay. I have certain thoughts in my brain. So the first thing is, again, in my brain, how I can format or structure these ideas into simple messages or sentences. So we call this, or the first component of the communication, we call it a message source. So the message source is, in fact, a component which is very, very important, which is the interface of the source user to create or to format the ideas or the information into well-structured messages. So the output here is some well-structured messages, okay? So now these ideas are converted to well-structured sentences or messages, okay? However, these messages, they cannot be transferred or they cannot be communicated directly. So we have to say these messages, for example, as a voice, okay? So that the voice can transfer through the air to the other person, right? So we have to convert these messages into some physical form, okay? Whether it's a voice signal or it's any type of electric signal or whatever, okay? Whatever physical form that I can convert this message to in order to send it to the other person, okay? So that happens through a very important component. So there is a component in the communication system which is used to convert these messages, okay, to a physical format that can be transferred. So what is that message? From people who have watched the video. So if you can raise your hand to answer the question. Anyone knows what this message, what this component is? عبد الرحمن خليلي تطوع و answered. عبد الرحمن, so عبد الرحمن, next time just raise your hand. So yeah, so it is in fact the transmitter, but يعني next time raise your hand so that I can consider your answer and give you the bonus. Okay, no problem, but that's just we need to يعني do it in an organized way so that we can all benefit. So that transmitter is the component that takes these messages and transfer it in a physical form. We'll talk about these other components later on, and try to interact using voice rather than text, because I will not be able to follow the text all the time. Okay. All right. So now the transmitter has converted the well-structured messages into a physical form. Okay. That can now be transferred over the physical medium. So the medium is the venue or the component that takes care of moving this physical format from one source to the other side. So by converting the well-structured messages into physical form, we are now able to transfer the physical form over the medium to the other side. Okay. So what are the type of media that we discussed previously in our lecture, at least 2 times back? So we talked about 3 categories of media in the network. So what are these types of media? Okay. And what is the type of the physical format on each medium? حسام يحيى اتفضل. يا good morning اتفضل. كابر حلو. electrical signal حلو. تمام. optical signals برافو عليك. third wireless برافو عليك. uses microwave signals برافو عليك. حسام يحيى. اوكي تمام حسام. اوكي طيب. So these are the types of media. Of course, for the person-to-person conversation, the only medium that we have is the air, and in the air we transform the well-structured messages into voice, and then the voice will go to the other side. Okay, but in networks we have different types of media like copper, like fiber optics, and wireless, and so on. So once we do this, on the other side, once the physical signal reaches the other person, the reverse operation will happen. So corresponding to the transmitter, so the transmitter is the interface to the medium, and then after the medium we have the receiver. Okay, so the receiver is the one that converts the physical format back to well-structured messages, which can be then consumed by the message destination or the message receiver. Okay, so these are the طبعا after the message destination, we now have the thoughts converted to or transformed to the other person on the other side. So these are the fundamental or the basic communication components. So the message source is the interface to the source user, and it's used to transform the ideas or transform the information into well-structured messages. Then the transmitter converts the well-structured messages into physical signal. Then the medium is used to communicate or to transform or to transmit the physical signal from one source to one destination. And then at the destination side or at the receiver side, we have the receiver, which is the one that converts the signal into well-structured messages, and then from the well-structured messages to thoughts, which is consumed by the message destination. طبعا the material talks about two other components here in the middle, here and here. Okay, so what are these two components and what they are used for? Can anyone tell me? Any idea what these are? عبد الله محمد اتفضل. ايوه اتفضل. اوكي. اوكي. That's Abdullah, that's the security, but the encoder itself actually is not necessarily used to hide the message. It's not necessarily used to hide the message. The decoder can be used, and I will consider your answer correct. The encoder is used to convert the well-structured messages into a more efficient and acceptable form that can be transmitted efficiently over the network. And I will talk about example, but then talk about the other component. What is the other component that corresponds to the encoder? The ايه؟ The decoder. Okay. Which it performs the opposite operation from the acceptable form of format for the messages. It recognizes this form back to the well-structured messages. So again, the encoder is used to convert these well-structured messages into a well-accepted form to be transmitted efficiently over the network. As an example, if I use a message source as a camera, so the camera actually it captures some video scenes from the environment, right? Whether it's people or any environment or trees or something like this. So the camera is our message source that converts the scene into well-structured messages. These well-structured messages are raw video packets or raw video messages. Okay, so I can actually transfer the raw video directly over the network, over the medium, or I can convert it to physical format using the transmitter and transmit it over the medium. There's no problem, which means that encoder and decoder are actually optional in that case. These are optional components. Some communication systems, they don't have encoder, they don't necessarily have to have encoders and decoders. But let's imagine that for the sake of this example that Abdullah عايز تقول حاجة؟ Go ahead. Right. Yes, exactly. Yes, more efficiently. It's not necessarily security. Not necessarily security. Although we can consider the cryptographic techniques and we can consider them as type of encoding. But the general function of the encoder is only to transform the well-structured messages into a more acceptable and efficient form that can be transmitted efficiently over the network. A clear example, as I said, is the camera which captures some scene from the environment, right? So these scenes are first transformed into raw video messages, right? I can transfer these raw video messages over the internet. Normally, I convert it to physical signal using the transmitter and I send it. I can do that. The problem with this is that this will take huge amount of resources from the network. So instead, we can convert the video into what we call مثلا MPEG-4. You know the MPEG-4 format or AVI or H264 or something like this. Any of the encoded format of the video. The benefit of this is that these encoders, these types of encoders, they can make video very, very efficient. They can compress the video information into less amount of data that can be transferred efficiently over the network. Okay, so that's the an example of of course for voice. For voice it's what it's MP3 مثلا. Okay, طب what about مثلا web pages HTML. Okay, so we can transfer the object or the different components on a web page as HTML. So these are types of encoding techniques and encoders that can again convert the well-structured messages into a more acceptable and more efficient format to be transferred over the internet. So the decoder, as we said, it does the opposite operation, converts the compressed or the encoded data into the well-structured messages again to be consumed by the message destination. واضح كده؟ All right, so now we go through this exercise, and this is one of the exercises that we will talk about many times in so this is a sample matching exercise. A simple matching exercise. So what I want you to do now is from this definition, you need to figure out which component here we're talking about and write it down here. And then I will give you 2 minutes to think about that, and then we will solve it together as a group. Yani. So I'll give you first 1 or 2 minutes to just go through this exercise and answer the communication component in this box here. Okay. Once you finish, please raise your hand too, so that I know that you have finished. Yani. Okay, so what is, yes, Muhammad Zihan, do you want to solve يعني the exercise? Okay, اتفضل. Message source. Right, so the source interface to the user is clearly the message source. So that's the one that converts the information or the thoughts into well-structured messages. All right. And then anyone else? Anyone else? Anyone else? طيب ماشي. Encoder. The encoder is the one that converts information into acceptable form. Okay, that is more efficient to be transferred over the internet. And then the source interface to the transmission medium. Huh? Transmitter يعني. Transmitter. This is the source interface to the message media. So again, I have here so the user is here and the destination is here. So the interface to the user is the message source, and the interface to the transmission medium is actually the transmitter. And then what recognizes information into the raw data? Decoder, bravo عليك. Which is here. Recognizes معناها ايه? It decodes the encoded data into the raw data or the well-structured message. Then used to send the information to the receiver. What is that? Medium, bravo عليك. So this is the medium that sends the physical representation of the information to the other side. And then the receiver interface to the user, message destination. Of course, this is the interface to the receiver, to the receiver on the other side. And then the receiver interface to the transmission medium. Bravo, Alec, yes. This is the receiver. When we say the receiver interface, the receiver refers, by the way, to this part. This part is all the receiver, and this part is all the transmitter, or sorry, the sender, right? So when we say the receiver, okay, we mean this part, the part on the right-hand side, okay? the receiver interface to the transmission medium. So to the transmission medium. So the first thing after the transmission medium on the receiver side is in fact the receiver, which is the component that takes the physical representation and then converts it to the raw data again. Okay, so that's an example, quick example of an exercise which is a matching exercise. It's very, very common activity that we will do throughout the class, and hopefully going through these types of activities will allow the students to understand the material more efficiently. So we'll